Okay, so let us solve some example based on superposition theorem. Okay, so actually in this diagram, this is a line over there. It is not clearly visible. So keep in mind, this is a line. It is connected. Okay, it is connected. Use the superposition theorem to determine the current through this 1 ohm resistance. So using superposition theorem, we have to calculate the current through the 1 ohm resistance. This is the one voltage source is given and one current source is given. So we have to calculate the current flowing through the 1 ohm resistance. Okay. So in superposition principle, you have to consider at a time only one source. We have to consider at a time. Okay, so as we have to consider one source at a time, so let us consider the 6 ampere source is acting alone. As the 6 ampere is acting alone, we will consider this voltage source as a shorted. Okay, voltage source as a shorted. We will consider this voltage source as a shorted source. So voltage is shorted or replaced by internal resistance, but internal resistance is not given, so voltage source is shorted. Okay, so as the voltage source is shorted, what is the current? We'll assume that in this path itself, the current is indicating 6 ampere. In this part, we will assume that the current is I in this direction, and in this part, this is the shorted, whatever the current through the 3 ohm, the same current is in this loop, that is current to the 3 ohm it is of I ampere. So if I apply the KVL in this loop, what we'll observe? 5 I minus 6, because it's 5, I is in this direction, 6 is in this direction, so I minus 6 ampere, so I minus 6 plus 1 I, that is 1 I, and plus 3 I is in this direction, I this is in direction, so I minus I is equal to 0. So 6I minus 30 is equal to 0, so I is equal to 5 ampere, and the direction of the current is from right side to left side. Okay, considering the 12 volt acting alone, so if we consider that 12 volt is acting alone, so keep in mind this line is connected. It is not showing in the diagram, but it is actually connected. It is also actually connected. If it is considered 12 volt acting alone, so 6 amperes is considered as open, as it is a current source. Current source is considered as open circuited. So current source is open circuited. As it is open circuited, so these are two loops we are getting. So I1 and I2, if we apply the KVL in this I1 and I2 loop, so I will get the two currents I1 and I2. So the current through this 1 ohm resistance, this current through this 1 ohm resistance in this direction, so current through this 1 ohm resistance is in 2 ampere. Okay, so by superposition principle, when both sources are acting simultaneously, current through the 1 ohm resistance is what? Current through 1 ohm resistance is, both sources are acting, this current is in this direction, this current is in this direction, so total current is equal to I dash plus I double dash, so is equal to 5 plus I double dash is equal to 2 ampere, so 5 plus minus 2, that is equal to 3 ampere, which is flowing from this direction to which is flowing from this direction to this direction, or from this direction to direction, it is minus 2. Okay, minus 2. Okay, next we'll see some example based on the Thevenin's theorem. In this Thevenin's theorem, so sorry, here is also this line is connected. We want to calculate the current flowing through this 10 ohm resistance using the Thevenin's theorem. So we have to calculate the current flowing through this resistance through the 10 ohm resistance. So first step of the Thevenin's theorem is what? Open the resistance through which the current is required. So 10 ohm is considered as open. So we have to determine the voltage across this, that is VTH. So applying this KVL here, I will get, if I apply the KVL in this loop and in this loop, so I will get two equations. If I solve these two equations, I get the I1 and I2 value. After getting I1 and I2 value, what is the VTH? VTH is nothing but the voltage across the 6 ohm resistance. So VTH is equal to 6 into I2, that is 6, and current flowing through this is I2, so that is I into R is the voltage drop across this, so it is VTH is equal to 6 into I2, so it is 3.912 volt. Okay, so we want to find out the RTH. To find out the RTH, this voltage source is replaced by shorted, or its internal resistance. As the internal resistance is not given, it is shorted, and looking from this terminal, looking from this load terminal, if we look under this terminal, we have to calculate the RTH. So again, we have to do the network reduction. If we want to do the network reduction, so this 5 and 3 are in parallel with each other in series with 2. So if we resolve this, so 5 into 3 divided by 5 plus 3 and plus 2 ohm, so it will give you 3.875. So this will give 3.875. This 3.875 is in parallel with the 6 ohm. So 3.875 parallel with the 6 ohm, it will give 2.35 ohm. That is RTH is equal to 2.354 ohm. So Thevenin's equivalent circuit is VTH and RTH. So VTH is 3.912 and RTH is 2.354, and again connect the load resistance of 10 ohm, which is removed from here. So 10 ohm resistance is again connected over here. So VTH divided by RTH plus RL, that is 3.912 divided by 2.354 plus 10, so it will give you the current of 0.3166 ampere. Okay, thank you.